Hello, my name is Valeska Ting. I'm a professor of smart nanomaterials at the University of Bristol. And my area of research interest is in porous materials that do interesting things. So some of these materials are good for hydrogen storage. Hydrogen is very difficult to characterize, and that's why we like to use facilities like ICIS and neutron scattering to be able to interrogate our materials.
Hello, my name is Nuno Bimbo and I'm a lecturer in chemical engineering at the University of Southampton. And my research interests are on porous materials for gas storage or separation or energy applications such as batteries or supercapacitors.
Hello, I'm Mi Tian. I'm a lecturer in low carbon engineering at the University of Exeter. And my research interests focus on hydrogen storage materials.
The advantage of storing hydrogen in a porous material is that hydrogen at room temperature and pressure is a diffuse gas. So it's very light, but it takes up a lot of volume. So if you want to put it through a fuel cell to power a car, for example, then you need a huge volume of hydrogen to be able to drive the vehicle 300 miles before you fill it up again.
Using materials to store it in solid materials or either solid or liquid state and make it safer and we hope more efficiently and economically.
The thing that I really liked about neutron scattering is that it can give you information that you can't get from other sources, and so you can really find out what's happening inside, say, the tiny pores or the atomic structure of different materials, and it can give you real atomic insight.
My involvement at the time, so I did some of the neutron experiments too. I was more involved with some of the modeling studies that we were doing. So we were seeing some indications from the modeling that the hydrogen would probably be very densified inside the pores, which was one of the reasons why we wanted to use the neutrons.
So a nice element of the work that Nuno brought was this modeling where you could look at the properties of the hydrogen as a whole over the whole material. But another really good thing about neutrons is you can have specialist sample environments. So you can look at really high pressures, really low temperatures, and really interrogate what your materials are doing as a function of pressure or temperature, and look at the in situ interactions of your material with different gases or liquids or different environments. The teams that helped us with our pressure experiments and our low temperature experiments, they were amazing. They're so knowledgeable, and they explained as they set up the instrument. So it's a really good opportunity to learn.
Our local contact swimmer provide the comprehensive trainings. That's really important, I think, to open the door for me. When I thought about this, it's so difficult. It's a physics, I don't want to touch it. But then swimmer explained everything to me. It's so clear. The powerful technician team is really, really good. World class.
I think it's a good example of how fundamental science can have very direct implications and applications, because in this case, using the tools that ICIS provides, neutrons, we can understand these interactions with materials better, which will allow us to synthesize better hydrogen storage materials. There's a very clear path between understanding these materials, improving on them so they can store more hydrogen, and then eventually have these resulting in applications so that hydrogen can be more widely used and can be more affordable.
The types of research that we're doing, like looking at fundamental materials science and materials chemistry, can feed into the engineering design of different systems, the development of new materials, and we'll need that if we want to mitigate the effects of climate change.